Hello, everybody, and welcome to our new book. It is blue and it says Expressions and Equations 3 on the side. And we're going to our vocabulary page, the very first page. Make sure you write these down. I notice some of you don't write them down. Please do. So these are notes. So the addition properties of equality. The word equality means something is equal. And property in math means a rule. So it doesn't mean somewhere you live, it's a rule. And equality means it's equal. And addition means you're going to add something, right? And so remember when we talked about equations and I said equations have an equal sign and something on both sides of the equal sign, and they are like a scale. And so if you think of one of those scales you sometimes see that have what's called a fulcrum, and something is on the left side, which is in math an amount, and something is on the right side. And if you put a weight in the same weight on both sides, your scale will balance. And that's what an equation is. The middle here is where it balances. So the same amount on the left side and the same amount on the right side will balance your scale or your equation. If you put something on the right side and not on the left, what will happen is the scale goes down and up on this side, and it will not balance anymore. So when we add something to our scale, we have to add the same amount to both sides to keep our scale in balance. And that's kind of what this says, this rule. So imagine I'm adding a weight to this side. And by the way, the same works with subtracting. If you take something away on the left side, you have to take something off of the same amount on the right side to balance back. So adding and subtracting are really both very much entwined. So let's imagine a little weight, like a little metal weight. Sometimes you actually see people putting these little metal weights on to weigh something, but I have to add the same weight on the other side, correct? It has to weigh exactly the same. And our goal is always to make these equations balance. So imagine this weight to be a number. Let's say it's number 8. Well, if I add number 8 to this side, I have to add number 8 to that side to balance it. Or if I take away a number, let's make it 2, I have to take away the same number on the other side. So that's what this rule says. So, and I'm going to write that you can add or subtract and you're wondering, why is it not called subtraction property of equality? I'm not sure if there is such a property, but adding and subtracting are very much the same in this respect. So they're only using one word. So subtract means take away. The same amount, it has to be the same amount. And an amount is like a number. To both sides. The key is both sides. Of an equation. Without changing the equation, you still have the same weight. It's still going to balance. I'm just going to say changing it. So for example, what does it look like? Let's say I have a number and I'm making up a number, let's say 9. And on the other side, I have a 9 also. That balances out, correct? Well, if I add something to this side, let's say I'm adding a 4, and then I have to do the same to the other side. I'm still balancing, correct? So I'm adding 4 here and I'm adding 4 there. So I still am in balance. I haven't changed. I changed the amount here, but the balance is still the same. So you're wondering, why am I having a 4 plus the plus is in front? This is also a positive 4. The 4 is positive, means you're adding a positive weight. Now, if I subtract it, then I would have to put a minus in front, but I don't want you to copy that because I'm just changing it. Then I would have to put a minus here because I'm subtracting it from both sides, and I still have the same amount. Don't erase it. You can keep your old example. -4 plus 9 is 5. 9 minus 4 is 5. So it works with both. Okay. Addition property of 0 means you can add 0 to any number and not change the number or the answer. And not change the number. In other words, you're adding nothing. Same with subtracting. Again, it means also adding or subtracting. It works the same way. So you can add nothing. For example, I'm taking a number. I'm picking any number, by the way. And if I add 0, it's still 5. You notice nothing changed. Or I can subtract 0 and it's still 5. So adding or subtracting 0 does not change anything in our problem. The additive inverse property says the sum means adding, and again it's subtracting as well. The sum of a number and its opposite is always 0. Or let's say equal to 0. Okay, so the sum of a number and its opposite. And you're wondering, what is that opposite? So that's talking about the sign. So for example, +3 and -3 are opposites because they have opposite signs, but the same number. So if I add +3 plus -3, +3 plus -3, the answer is 0, right? Or how about another one? -3 plus 3. If I reverse the order, it's still 0. When I use a number line, I can see you have 3 positives and 3 negatives. And the distance, they meet in the middle at 0. Yeah, so that's where the 0 comes from. They're the same distance, so if you add them or subtract them together, you end up at 0. Okay, that's the additive inverse. And now multiplication property of equality. So multiplying rule of equals. So if you multiply, so we're going to say you can or multiply any number by 1. Oh, no, you know what? That's another one, sorry. You can multiply both sides. Sorry, I need to start over with my sentence. Of an equation, left side, right side, by the same number. And I'm going to add or even divide, because dividing works the same way. Multiplying or dividing, they're using one word, but you can multiply or divide both sides. Again, it has to be both sides of an equation by the same number and not change the value of the equation. So for example, let's say I have an equation and I'm making up numbers, guys. 6 is equal to 6. That makes sense to everybody, right? But if I multiply both sides by 2, remember both sides by the same number, won't I have the same result again? That's all it is. It kind of makes sense, right? Still the same value, balances out. It might be double as much, but the balance is still there in our scale. It's all about the scale up here. See, it's the same when you add or subtract, multiply or divide. I'll show you a division one. So let's draw dividing. So let me bring up a number that I'm making up straight out of my head. How about 10 equals 10? And now I'm going to divide. Dividing is a fraction bar. You divide with a fraction bar. Let's divide that by 5. I'm dividing both sides of my scale by the same number, and I will still balance out. 10 divided by 5 is 2, equals 10 divided by 5 is 2. Still balanced. Nothing changed about the balance. Okay. So now last two here, multiplication property of 1. So that one makes sense too. If you multiply any number by 1, what happens? It will not change the number. So for example, you might say this makes absolute sense to me, but when you get into math more, I'm making up a number 7 and I'm multiplying it by 1 and I still end up with 7, right? When you get into math more, you'll see that these rules sometimes come into play, and then you're like, oh, now I get it. But hopefully then now you get it. We'll use these rules in higher math problems a lot. Okay, but they're really simple when you think about it. Multiplicative inverse. So the inverse is always when you flip something, most likely a fraction, right? So that's also called a reciprocal. So I'll write that word down, okay? So this means if you multiply a number by its inverse or reciprocal, that's a word you hear a lot, reciprocal. And a reciprocal is the fraction flipped upside down, okay? The answer is always 1. Always 1, no matter what. Here's an example. You can have a million numbers and it'll always be 1 when you multiply by the reciprocal, which is the same number but flipped upside down. Flipped. Okay, so for example, I made up a number. I said I'm using the number 3 and I want to get to 1. Well, to get to 1 by multiplying, if I multiply by 1, it's still going to be 3. So what am I multiplying by? So if you have the number, make it as a fraction. You can make any number a fraction by writing it above 1. Then you flip it and you multiply. Flip and multiply. So multiply and flip it. So 1/3, right? You see? Just move it upside down, right? That's called the inverse or reciprocal. So let me write that here. There we are. And so now if I multiply the top, remember we multiplied top and bottom. That's all it is. We're not, it's not like adding fraction where you have to have a common denominator. Multiplying fractions is super easy. 3 times 1 is 3. And 1 times 3 is 3. And 3/3 is the same as 1. And that's how that works. And this is what that property says. Okay, that comes in handy sometimes. All right, so we're done with this page. And tell me if you like me to scroll up or down when you do your videos. You know you can pause in reverse, but I don't know what helps the most for you. I don't want to rush you. A lot of times I think it's good to watch me do it and then copy it and then pause the video and copy. Because when you watch, you'll learn more than writing and watching and listening. So it takes time, yes, but you're more likely to understand the questions, right? And that's the goal. We don't want to just get it done. We want to get it done to where we understand it and know how to do it. And this page I'm planning on doing in class, so I'm hoping we find time. I'm going to write in class activity, and maybe you can remind me at the end of the book, hey, we still have to do this page, okay? It takes a bit, probably takes a whole class period, maybe 45 minutes. Okay, so this was page 1. Next page is page 2. And in this one, these getting started questions are sometimes pretty easy. So, but we're going to do them together nevertheless. But I'm going to have you work ahead and then I'll pause my video and then pop up the answers and you can check. So this one we'll call notes, but I'm going to give you a little pop quiz to see if you already know something ahead of time, right? Equivalent expressions are same expressions. They might look different, but they're really the same value. A cups and counters model. I don't see any cups and counters here, but they come later. We will apply properties, remember that's rules, of arithmetic. Arithmetic is adding and subtracting, multiplying and dividing numbers to generate or make equivalent, equal expressions that include integers, which are whole numbers, including 0, including all the negative numbers, and negative coefficient. What's a coefficient? Looking for one. 3 is a coefficient. It's a number that's in front of a variable. That tells us how many x's do we have. We have 3 of these x's. That's called a coefficient. We will use algebra, which algebra now uses symbols like x, y, and stuff like that to investigate 2 number tricks. I'm skipping that for right now, the number tricks. We'll do it in class. Okay, match each expression in column 1 with an equivalent expression in column 2. So this is your job. You need to see which one matches, right? And write the letter A through H, write each letter here. And then when I click back, you're going to check your answers. And if they're wrong, please change them. They need to be correct, okay? So I'm going to give you some time now, pause the video for everybody and see if you can figure out which letters go right here. So that should take you a few minutes. Please do not peek until you're done. It's not a big thing if you got it wrong. That's how we learn, okay? Okay, I'm hoping you paused your video and tried it yourself. I now realize that all my letters are in cursive. I'm hoping you still can read cursive writing. Okay, the first thing I looked at was double negatives. Means subtracting a negative means adding the opposite. So always circle those two negatives and put a plus. That's easier to match up, right? So I did that here. 4 minus -4 means you add the opposite. So 4 plus 4, that's a x plus 1. So subtracting a negative means add the opposite sign, add the expression. Okay, so that would be x plus 1. And this is, what is that, a 3? 3x plus 3x. Those are it. When you add a negative, adding a negative means you're just adding the opposite. So this whole thing turns into 0 because 4 plus -4, remember the opposites, turns into 0. This turns into 0. And this turns into 0. Okay, so let's look. 4 plus 4, it's F. 4 plus -4 is C because it's 4 plus, you can insert a plus in your mind here. You're adding a negative. It's still 0. G, x plus 1. Yep, because you're combining the two negatives. A, 4 is A. X minus 1, yep, that plus does not need to be there. You're adding a negative. It's still the same as x take away 1. Okay, so that's that. X plus x is B. X plus -x is D because that plus does not have to be there. It's assumed you're adding this negative. The result is still 0 here. 3 plus 3, that's this one, H, and 8 is E. Okay, so those are those. And now it's your job to, well, I'm going to have you do these down here as well. Pause your video in a second. First of all, let's look at this question 9 before we start that. Illustrate an important relationship between addition and subtraction. Subtracting a number gives the same result as adding the opposite. So subtracting and adding are so related. So everything can be put back to adding the opposite sign. And when we say opposite, we mean opposite sign. Okay. So I want you to pause your video again. This was on your final test, by the way, I believe. Yep. Yeah, I think so. And you can figure out how many x's and then here the same and how many numbers. Do not combine the numbers and the x's. So pause your video. Okay, check your answers. You have 5 plus 4 is 9x, -2 plus -9 is -11. This would be the answer for 10. And on 11, you had to distribute 8. So start from left to right, -6 plus 8 times x is 8x. 8 times -5 is -40. Finish the problem. So the first thing is parentheses. Do you have a 40 here or a 5? Do the both. To remind you, you got to multiply everything by 8. And now you combine your like terms. 8x minus 7x is 1x. -6 plus -40 is -46. So that's that one. So that was page 2. Do we have something on top? Notes. Yep. And now this page is also notes. And some homework. Cups and counters, the upside down cup. And so a positive counter looks like this, and the value is a +1. A negative counter looks like this, and the value is a -1. A cup looks like this, and the value is unknown, we don't know, that's usually an X, right? And then the upside down one, like that, is the opposite of the unknown, which is the negative. Oh, can I squeeze that in there? So it's the negative X, because this is the positive X. Yeah, usually we use X for the unknown quantity. You could use any symbol you like, but it has to be the same each time. That's the only thing. Remember, before I started with the heart, that's a number behind that heart. You got to just use one symbol and stick with it. Okay, so the opposite, this is new. This upside down, we now have negative X's. So I'm giving you the question and you draw. You're going to build and draw expressions. By the way, these are not equations because they don't have an equal sign. And an equation has an equal sign and something on each side that balances out. These expressions do not look like that. So this is not what we're doing, okay? So build and draw the number 4. And then build and I'm going to have you pause the first row. I'm giving you the numbers to build and then I'll pause the video and you do it and then see if you got it. Okay, pause your video. Oops. Okay, this is what it should look like. Check it out. Remember, the upside down is the new one. Okay, for number 6, you're going to build and draw x plus 2, x minus 2, negative x plus 2, and 2 minus x. For number 10, you don't have to do that now. That's going to be your homework. 3x minus 2, negative 3x minus 2, 3 plus 2x, and 2 minus 3x. So the ones I'm going to show you are these 2, and then the rest is homework. So homework, 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 homework. And I'm going to just do this one. So 2 is a number that's positive 2. There's no sign, it's assumed to be positive, and 1 negative counter. 2 is positive and 3 negative counters. That's what that would look like. And you do the rest. Okay, number 14, I want to show you. That's going to be how you do your homework on the next page. So it's important you pay attention. So here we kind of go backwards. I'm going to give you cups and counters and you have to come up with a problem. Notice we have 3 groups of the same, right? We have 3 groups of x plus 3, but there's 3 of them. So all you do is multiply that by 3. This is the mean as a product because you're multiplying by 3. Product means multiplying. And then when you write it without it, you have 3 simple x's and then 9, correct? 9 pluses, and that's as a sum. Because you have that plus or minus. Minus and plus are both sums. Because remember, you're adding. Anytime you add, it always comes back to adding. So then you need to write it as distributive property. So you can say that 3 times x plus 3, which is this part, is the same as or equivalent to 3x plus 9. And that is called distributive property. So this right here is how you do your homework. So you make sure you look at that on next page. Okay. One more. So I'm giving you the cups and counters, and you write the product and the sum and the distributive property. So you're having upside down counter means negative x and a positive 2, and you're going to have 3 groups of these. Notice 3 groups of the same. So as a product, you can write negative x. So one of them is negative x plus 2. That's just one of them, but you got 3 of them. That's product. Then we can write it separate. We got 3 negatives, so negative 3x, right? Plus 9. Oh, is it plus 9? No, plus 6. That's as a sum. And then we can say 3 times negative x plus 2 is the same or equivalent than negative 3x plus 6. And this is called distributive property. I'll just shorten it. Okay, this one we're skipping. You can cross it out. It made no sense to me when I looked at it. So therefore we're skipping it. Number 16. These are going to be filled in by me, by your notes. Copy. So up here we'll write copy, then build, and draw expressions. Again, I want to reiterate something. You might be confused about this expressions versus equations. This right here, what I'm circling is an expression. Do you see it? There's no equal sign. There's nothing. It's just, it's an expression. This right here, what I'm circling is actually an equation. Okay, this means you have a left side, you have an equal, and on the right side, it's the same value. It's all this. Both sides have this as your value. So that's an equation. Do you see the difference, everybody? I hear so many students say, oh, I'm going to solve this equation right here, this one. This is not an equation. So I'm like, okay, well, you're not solving an equation, you're simplifying. You can simplify this by writing 3x plus 9. You can make it more like user-friendly to see what's going on, but you're not solving any equation. Okay, so let's just get clear with that. 16. So I'm giving you an expression, and you have to build the expression, okay? So we have x plus 3 minus 2x minus 3. So this is the expression, correct? So now let's draw this out. You have one positive, that's this one, right? I always have to think. Positive 3, 1, 2, 3. Then you have 2 negatives, upside down, 2 upside down counters, and negative 3. So this is your build and draw. So now we have to come up with an answer. Notice the opposites I can cross out. Anything that has a match, I will cross out. This one and this one are opposites, so I can cross them out. The pluses, there's 3, and the 3 minuses cancel each other out. They all go away. Those are opposites. So what do I have left? I have to check. I got this left, which is equal to a negative x. Okay, so now we're going to do another question. So this is the answer. You can also do this by yourself. You can say 1x minus 2x is just a negative x, and positive 3 minus 3 go away. So this is my answer when I simplify. But the cups and counter model is another way to help you visualize this. So let's try -2. I'm making up a problem, okay? Minus x plus 2. Notice there's two opposites right there. Plus 4x. Now, the more advanced students will already know what this is. However, let's humor me and everybody who's maybe going, I'm not quite sure yet, to see if we can reason this out. This 2 has two negative counters. Negative x is an upside down. Plus 2 is two positive counters. Plus 4x is positive. So we're going to have up, right side up, like a V, right? Now let's look what we can cancel out. We got two negatives, two positives, these cancel out. We got the ones that are upside down and right side up, there's these two cancel out. So what do I have left? Make sure I'm skipping nothing. 3. I got 1, 2, 3. V's is 3 positive x's, and that's my answer. Okay, one more. -1 minus 2x plus 2 plus 5x. Let's do this one for homework. So I'm going to have you figure that one out. 19, it's a little different. Look at this one. It has a -3 and then x plus 2 in parentheses. So I have x plus 2 groups, but not 3 of them. I have the opposite. So this just indicates opposite of everything. Opposite of everything you think. So this negative out front, watch. So now instead of having a positive x, I have the opposite. This is an upside down and these two are going to be negatives. So I'm changing everything. That's what that negative does, right? So let's count that together. -3x minus 6. That would be the answer. Another way of looking at it is if you distribute or multiply everything in the parentheses by -3, you can say -3 times x is -3x, excuse me, and -3 times +2 is -6. Okay. And one more, and then this one is homework. -3, again, that negative changes everything, x minus 2. So that changes everything around. My x's are going to be all of a sudden upside down, and my -2's are all of a sudden +2's. And I got 3 groups. That part stays. So look at the answer. It's -3x plus 6. So this one is homework. I'll give you the question. -x minus 4. Okay, so I want to see if you can figure that one out. So that was page number 3. Okay, and this is homework. Build and draw the following expressions. Remember, cups and counters. Okay, cups, so use, and counters. And then backwards. This is backwards. So you're ending up with something like this. And then on this one is just like the previous page where I said this is like your homework. What does it look like as a sum? On this one, I would just multiply it out. It's -2x -2 times +6 minus 12. Okay, that would be the answer for that one. And you do all these. And then I'm going to give you 8, which is a little tricky. Evaluate the expression when x is 10. So you're going to plug in for every x the number 10 and come up with one number answer for this whole expression. That's what evaluating is. Some students call it plug it in, plug in x. I don't like plug in. Okay, but that's a lot of times using that word. It's called evaluating. Yeah, so here comes a 10. Yeah, a 10. Remember, this is 3 times 10. Here's a 10. And you figure out what the answer is. So the answer is a number, one number. Let's see if you can do that. And then you have to simplify it, combine all your like terms and do it again and see if your answer matches and wonder why. Hopefully it matches. And then you're doing 9, 10, 11. So this page right here. And I believe the next page we're gonna have to do in class. Those number tricks, I'm going to try to do that in class. And I believe that's our last page. Yep. Okay, good luck to you guys.